leopards. Okay, we're back with me, Miss Smith, to talk about special right triangles today. Now, what makes a right triangle so special? Well, I'm going to show you here in just a second that there are some properties of what we call a 45, 90 degree right triangle that will be true for every single 45, 90 degree triangle in the world. Miss Smith, what does that mean? Well, let's do a little review and let's go take a look. Okay, first of all, I need you guys to remember that an isosceles triangle has two congruent sides. It also has two congruent base angles, and a right triangle has one right angle and two acute angles. Okay, so how does this apply to the special right triangles? Well, guys, we're going to start by talking about an isosceles right triangle. Every single isosceles right triangle in the whole entire world, no matter how tiny, no matter how big, every single isosceles right triangle in the world is what we call a 45, 90 degree special right triangle. It has two congruent sides, two congruent base angles, which are each 45 degrees, and one right angle. Hence, 45, 90 degrees. So again, I'm going to say this. Every single isosceles right triangle in the entire world is a 45, 90 degree triangle. And I'm going to show you guys some ratios that apply to every single isosceles right triangle that is a 45, 90. But first, guys, I want to refer back to something about a square. You guys remember in a square that we have a diagonal. So this diagonal right here, remember, in a square, it bisects the opposite angles. Oh, well, that means that we're going to have two congruent 45, 90 degree triangles that we can make from one square. Okay, so I'm going to say that again. When you have a square, you can cut it in half through the diagonals and you will have two 45, 90 degree triangles. Now, what makes these 45, 90 degree triangles so special? Well, guys, let's take a look at these side lengths. Okay, so, and I'm going to get over here. Okay. What makes it so special is that regardless of how big or how small any of these right triangles are, the 45, 90s, what is always true is that the hypotenuse is the square root of 2 times as long as each leg. What? Okay, hang on. Let's take a look at this. Here's what that means. And guys, this is on your formula chart and on your flip chart. If you look at this right here, it says that the ratio is x square root 2. Okay, so where do we place these ratios? So I want you guys to notice something. Across from the 45 degree angle is a leg. We're going to label that as ratios of x. Across from this 45 degree angle, that ratio also has an x. But notice the hypotenuse, which is across from the 90 degree angle, has the x square root 2. Okay, so here's something that you might want to write down. Okay, so I'm going to rewrite this. So we have x to x square root 2. Across from the x is the 45 degree angle. Across from the other x is the 45 degree angle. And across from the x square root 2 is the 90 degree angle. Okay, so these ratios, what we're going to do is we're going to use these ratios to solve for the measurements. Now, we could use the Pythagorean theorem if we have two side lengths. But guess what? We're only going to have one side length and we're going to have to solve for all the others. Okay, well, I'm going to show you how. Now, I'm going to say this and I'm going to say it and you guys will hear all of your other geometry teachers say this. Very, very important, ladies and gentlemen. Okay, when labeling your ratios, and yes, you must label your ratios. Always put a box around the ratios. Okay, so we're going to be looking for that. Okay, that way you can tell the difference between the ratio and the variables. And you guys are going to see the further we get into trigonometry, this is going to make a difference. Okay, so Miss Smith, how does all this stuff work? Let's go take a look. Hey guys, we're going to start with number 5. So go down and I'll meet you at number 5. All right, you guys know the drill. Before we get started, read the instructions. Okay, so ladies and gents, look, it says that first of all, we must label the 45, 45, 90 degree ratio on each triangle and put a box around the ratio. Again, you're not going to get credit for the assignment unless you put a box around your ratios. Then you're going to apply the property of the special right triangle to solve for z, and we're going to leave our answer in reduced radical form. Hey guys, if you need to make yourself a note, reduced radical form, no decimals. Okay, that's another thing we're going to look at. No decimals in reduced radical form. Okay, so let's go down and look at number 5. All right, so let me scroll on down. All right, so number 5, I'll make it nice and big right here. So we're going to solve for z. Okay, so looking at your figure, the very first thing that we're going to do is we're going to label the picture. Okay, so if you guys see this has one congruent angle here, one congruent angle here, that means that it is isosceles because we have two congruent angles, which means we're going to have two congruent sides. Okay, and each of these angles is going to be 45 degrees. Okay, now across from the 45 degrees, that's where we're going to label our ratios. So across from the 45 degree, this ratio is going to be x, and I'm going to put a box around it. Across from this 45 degree angle, this is also going to be x, and I'm going to put a box around it. Okay, and then across from my 90 degrees, that is going to be the ratio of x square root 2, and I put a box around it. Now, guys, what we're going to do first, very first thing that we want to do is we want to solve for x in the ratio. So what does that look like? Okay, so you're going to start with what you know. Okay, ladies and gents, do you see that we know that this side length right here, we know that that side length is 7, okay? Guys, I totally just got distracted because one of my cats outside just walked by my door and just poked his head up on the glass and was like, hey, what are you doing? You know where his nose presses against the glass? Totally. I got distracted. Okay, so let's get back to where we were going. Okay, 7 square root 2. We're going to start with that because we know that side length. Okay, so I'm going to come over here and I'm going to label something. And this is how you guys are going to see it. All right, so let's go over here. Okay, so we have two side lengths that have the x, and the x square root 2. Okay, across from one of the x's, okay, we have the variable of z. Across from the other one, well, hey guys, if one of these is z and they're congruent, then shouldn't that other side also be z? Yes. And then across from the x square root 2 is the 7. So again, we're going to start with what we know. We're going to start right here, solve for x, and then go back and plug it in. Okay, so if we're going to solve for x, guys, these two expressions, 7 and x square root 2, they represent the same thing. So that means that they are equal. So we're going to set them equal to each other. Okay, so then I'm going to zoom in here so you guys can see this. X square root 2 is equal to 7. Now, guys, we're going to use all of what we learned about with exponents and radicals to get x all by itself. So to do that, guys, we have to divide both sides by the square root of 2. Okay, so now these reduce to 1, so we just have x equals, well, hey guys, 7 over the square root of 2. Am I allowed to keep it in that form? Do you guys remember? Is this legal? No. This is not legal. We can't keep it in that form. Remember, no radicals in the denominator. All right, so again, I'm going to zoom in here so we can focus on just this first. No radicals in the denominator. So we need to multiply both the numerator and the denominator by the square root of 2 to get rid of the radical in the denominator. So now we have 7 square root 2 over 2. Okay, can we reduce this? Okay, so guys, we really can't reduce it because remember, in reduced radical form, there's no decimals. Okay, we could say that 7 divided by 2 is 3.5, but that's a decimal. We don't want that, so we're going to leave it. So, ladies and gents, this right here is the value of x. Okay, this is what x equals. So now I can take this x and go back and plug it in to both of these expressions. So if x equals 7 square root 2 over 2 and x equals z, oh, well then that means that z also equals 7 square root 2 over 2. I know, lots to do, isn't there? Okay, so if you need to make yourself a little note, okay, first thing, okay, label your ratios and put a box around them. Second thing, start with what you know. Solve for the x in the ratio, then go and plug it in to all of the ratios. Okay, so that's just what we did. All right, so we're going to work another one to get you guys in the groove. Okay, let's go down and take a look at number 9. We're going to go take a look at number 9. I'll meet you down there. Okay, on number 9, there's multiple parts, but the very first thing we're going to do, label the ratios on the triangles. So remember, okay, and it tells us here that we have a square. Okay, so in a square, okay, we know that a diagonal, okay, and this said it on our notes, a diagonal cuts the square into two congruent 45, 45, 90-degree triangles. So this is 45, this is 45, this is 45, this is 45. Now I'm going to look at just one of those triangles and I'm going to label the ratios. Okay, remember, across from the 45-degree angle. Okay, which ratio should I put across from the 45-degree angle? Okay, well, what about the ratio across from this 45-degree angle? So what ratio should I put across from the second 45-degree angle? Okay, and lastly, guys, what ratio should I put across from the 90-degree angle? Okay, let's see if you guys were on track. Okay, so we're going to do this. We're going to say this is x. I put a box around it. This ratio is x. I put a box around it. This ratio is x square root 2, and I put a box around it. Okay, so make sure that's the first thing. Second thing is we're going to start with what we know. Okay, we're going to start with what we know. Well, guys, right here, we know that 3 meters and x square root 2, they equal each other because they're on the same line. Oh, okay, so that will help us to solve for x, and then we can go and plug x in to get the side length, can't we? Okay, so let me zoom back out, and let's go take a look. I just said, okay, that the 3 meters equals the x square root 2. Okay, now we need to solve for x. Okay, so what should I do now? Well, I'm going to divide both sides by the square root of 2. Okay, those cancel out, right? Reduce down to 1. So now I have 3 over the square root of 2 equals x. All right, guys, this is where I want you to use those skills that we learned during applying radicals. And I want you to tell me, I want you guys to solve it and tell me, what do you guys get for x? Okay, go solve it and tell me what you get. Okay, the more we practice this, how are you guys doing? Okay, so hopefully you should have gotten for the side length, okay, and this is just for the side length, is that you should have gotten 3 square root 2 over 2. And guys, remember, it's in meters. We got to remember those units. So 3 square root 2 over 2 meters. That is the side length. Okay, now it's asking us to find the area and the perimeter. Hey guys, you guys have done area of a square before, but just in case you forgot what the equation is, it's on your formula chart. You know, that bright yellow formula chart that we gave you guys. Okay, so the area of a square equals base times height. Okay, so we got to figure out what's the base, what's the height. Do you guys remember I said that the base and the height will always intersect at what kind of angle? Yeah, I said this in the last video. Base and height will always, always, always be perpendicular, right? So our base and our height. So right here, let's see if I can highlight it so you guys can see. Here could be the height. Here could be our base. Well, hey guys, in a square, aren't the base and the height exactly the same? Yes. Okay, so we're going to plug this in. Area equals, okay, and if I can get back to the right pen, area equals, okay, 3 square root 2 over 2 squared. So we're going to multiply it times itself. Actually, let me write this out. Okay, we're going to write this out. So it's 3 square root 2 over 2. Oh my goodness, that's a lot of math. That's why I'm doing this one with you guys, right? Okay, so guys, there's something you can remember about radicals and fractions. First of all, you're going to multiply straight across the numerator to the numerator and the denominator to the denominator. You multiply whole number to whole number and radical to radical. Okay, so in the numerator, if I do, and I'm going to highlight this, whole number to whole number, 3 times 3 would be 9. Okay, and then I do radical to radical. So square root of 2 times the square root of 2. Hey, guys, the square root of 2 times the square root of 2 is just 2, isn't it? Then I do the denominator. 2 times 2 would be 4. Now that's a little bit more manageable, isn't it? Okay, so, guys, remember, we want reduced radical form. We don't want any decimals. Can you guys tell me, I want you to solve this out the rest of the way, and what do you get for the area of this square, including the units? What do you get? Did you guys remember to reduce? Did you remember your units? Okay, so you should get 9/2 meters squared. That is the area. But wait, we're not done. There's more. We need to find the perimeter. Okay, so how do we find the perimeter of something? Well, we add up all of the side lengths. And in your formula chart, it shows you that the perimeter of a square just happens to be 4 times the side length. Hey, wait a minute. We know the side length, don't we? The side length was 3 square root 2 over 2. So this would be 4 times 3 square root 2 over 2. Holy bejesus, Miss Smith, this is a lot of math. Yes, I know. All right, so let's work this out together. Okay, so guys, I'm going to zoom in right here and I'm going to show you guys something. We can actually reduce this, simplify it before we even start. Okay, 2 goes into 2 once, 2 goes into 4 twice. So we have that this equals 2 times 3 square root 2. Let me erase that and make it to where you guys can actually see it. 3 square root 2. And now that's a little bit more manageable. Remember, whole number, radical to radical. Okay, so this ends up being 6 square root 2. Again, whole number to whole number, but the radical to radical, there's no other radical. So the perimeter ends up being this, and remember our units. 6 square root 2 meters. Okay, meters. Whew! We're finally done with this problem. Yes, we are. Now that's a lot of work. Hey guys, but you just solved a problem here where all we know is the diagonal length, and you were able to find the side length with just one expression, one side length, right? By the way, did you guys know that when they tell you that you have like a 60-inch TV, that's actually the diagonal length? Oh, yeah, I don't know if you guys knew that or not. Just a little tidbit from yours truly, Miss Smith. Okay, you guys want to do one more together? Let's do one more. Let's go down and take a look at number 12. Go to number 12. All right, here we are, number 12. Guys, please read through this carefully, okay? It says a girl is flying a kite. It's supposed to say kite, isn't it? Okay, a girl is flying a kite. Now, she is holding the string 4 feet off the ground. The length of string between her hand and the kite is 12 feet. We want to determine how far off the ground the kite is. So, guys, we're assuming that between her hand and the kite, that the string is tight. It's not droopy, okay? It's tight. Now, I want you guys to notice something right here, okay? Notice the markings on this particular triangle. This is an isosceles right triangle. Okay, I said that there was something true about every single isosceles right triangle in the world. What did I say is true about every single isosceles right triangle in the world? That's right. I said that every single isosceles right triangle in the world is a 45, 45, 90-degree triangle. So that means that we can use the ratios for special right triangles to solve for this. Okay, so it says we want to draw and label the triangle. So we're going to go down and draw and label the triangle, and then we're going to label the information, and we're going to find the height of the kite. Okay, so here's what this looks like. The only reason I'm coming down here to redraw the triangle is so that you guys can see what we do at the very, very end. Okay, so we have a 45, 45, 90-degree triangle. Okay, we're going to label our ratios. Across from the 45 is x, across from the 45 is x, and the hypotenuse is x square root 2. Now, can you guys tell me, what did I forget to label on the new triangle that I drew? What did I forget? Hopefully you guys said, hey, Miss Smith, you completely forgot to put that the hypotenuse is 12 feet. Ah, that's important information. Okay, now we're going to start with what we know, and we're going to go solve. We know this side. We know that right there, 12 feet equals x square root 2. All right, well, let's go over here and let's work this out. Okay, so x square root 2 equals 12. Those equal the same thing because they're on the same line. Now we're going to get x by itself so we can go back and plug it into the ratios. All right, guys, I started to set it up for you. You guys use your knowledge and skills, your brains about exponents or radicals, and I want you guys to tell me, just solve for x, not the height of the kite. I just want to know, what do you get for x? Okay, did you guys remember to reduce and simplify at the very, very end? Right? So x equals 6 square root 2. So what does that mean? Well, guys, that is our side length right there, isn't it? Okay, so that means that right here, and I'm going to go back up to the original figure. Okay, that means that right, and I'm going to put it right here, these side lengths are 6 square root 2. Okay, and yes, they're feet. Okay, 6 square root 2. It's asking us to find the height of the kite. Guys, that means that we want to find, okay, and I'm going to highlight it, we want to find the distance from the kite all the way to the ground. So we want to find that entire height. Well, guys, if from her hand to the ground is 4 feet, then right here, this to the ground is also 4 feet. So in order to find the height of the kite, I need to add these two together, right? Because part plus part equals the whole. Okay, so what does that look like? Okay, this is what this looks like. Okay, so let me go back over here. All right, so I would have 6 square root 2 plus 4. All right, does our answer say to leave in reduced radical form? What do you guys, look up there. Does it say to leave in reduced radical form? No, it says find the height of the kite and round to the nearest tenth of a foot. Oh, thank goodness, Miss Smith. Now we can actually put 6 square root 2 in our calculator plus 4. Okay, so when you put 6 square root 2 in your calculators, guys, you should get, and I'm doing this right along with you, that this is 8.485 plus 4. And guys, when we add the 4 to that, my calculator is not working, okay? We get that this is 12.485. Okay, so we're going to round it to the nearest tenth. And when we round it to the nearest tenth, that should be 12.5 feet. 12.5 feet. Don't forget your units. Okay, and the reason why is because the 8 rounds up that 4 to a 5. Okay, all right, so again, these problems are longer. There's going to be some problems that are going to have more of a word problem feel. Yes, that's where we're going. Okay, there's going to be more word problems. So guys, just take it one step at a time. Remember, okay, label your triangle with the ratios. Put a box around them. Start with what you know. Solve for x in the ratio, and then go back and plug x in to all of the ratios, and that will help you to be able to solve these problems. Okay, guys, hang in there. We're going to get through it. I'll see you in class. Adios.